For this lecture, we will start with the cardiovascular system. So, the cardiovascular system consists of what? What are the main composition of the cardiovascular system? When you hear the cardiovascular, what does that mean? Cardio mean the heart, and vascular, the blood vessels. So, it is consists from the heart, the cardiovascular, the blood vessels, and also what's going inside them?
Blood.
The blood. So, the heart, it is the engine that pumps the blood to the whole body part through the pathway, which is the road that the blood vessels are going through, and the blood is the vehicle that carry all nutrient, oxygen, and all of other things. So the cardiovascular system, it is a transport system. So transport vehicle, which is the blood, and also a road for the blood to pass, which is the blood vessels, and also the power and the engine that it will not stop from the beginning of life until death. If that engine is stopped, it means death. So it is the heart. So the heart is working all over our life, from the beginning of the life until death. So the cardiovascular system, it is a closed system of the heart and the blood. It is a closed system because the blood is going in a closed circle. The heart pumping the blood, and the blood vessels allow the blood to circulate all over the parts of the body. Then the function, as we discussed in blood in the previous unit, the function of that is for what? Transferring of nutrient, waste, water, hormones, respiratory gases, and also maintaining of what? Heat and temperature of the body, and also maintaining electrolyte balance. All of that, it is done by the blood or the circulatory system. So the function, it is deliver oxygen, nutrient, and remove carbon dioxide and other waste, produce in the body, and the end product of metabolism. Objective, we will describe the location of the heart in the body, identify the major anatomical areas, then trace the pathway of blood through the heart and compare the pulmonary and the systemic circulation, then name the function of blood supply to the heart, and name the elements of the intrinsic condition system, the conductive system of the heart, and describe the pathway of the impulses through the system. Define systole and diastole and cardiac cycles, then describe the control of cardiac output in terms of heart rate, stroke, volume. So, about the location of the heart. Where does the heart is located? In the thoracic cavity. So this is in general, the heart is located in the thoracic cavity. Which part of the thoracic cavity? It is, we can say that it is in the middle of the thoracic cavity. What is there from the right side and left side?
Right.
There are the two lines. So it is coming in between the two lines. And from the frontal side, what are there? Anteriorly, what is there?
Lungs.
Sorry?
Lungs.
Lungs, yes. They are part of the lung. It is coming over it, but also it is the thoracic cage or the sternum, so it is mainly under the sternum. And from the back also, it is the back of the chest. So the heart posteriorly, when we are dividing it, we have to see from posterior, anterior, superior, and medial. So from posterior, sorry, what is there posterior to the heart? Vertebral column is there, and also it is the anteriorly thoracic cage and sternum. From above, what is there? Superior. Part of the lung and also blood vessels. It is medial to the two lungs. It is found in the thoracic cavity. So, if we are taking the position of the heart, see here a triangle, and this is the head of the triangle. So, actually the heart, mainly we are saying that the heart is situated in the left side of the thoracic cavity. But actually, it is not situated in that. It is situated mostly in the middle of the chest, but the apex of the heart, it is going toward the left side. It is pointing to the left side. So the base of the heart is coming up. The apex, it is diverted toward the left side. So this is what we call it, the apex of the heart. Here, this is the base of the heart. So it is upside down. So the base is up and the apex is down according to the body. So about the size of the heart, who can tell me about the size of his heart? How much is it? What is the thing that resembles that? Yes, it is the, thank you. So it is around the fist, the size of the fist, of our fist. So the weight of the heart, it is less than 500 grams. This is in an adult. In small children and infant, it is very small. It is less than 200 grams. It is cone shape. The shape of it is cone shape. The location, as we said, in the thoracic between the two lungs, and pointed the apex direct toward the left hip. So the apex, it is directed toward the left hip. Rest on the diaphragm. So that base, the apex, it is rested over the diaphragm. At the fifth intercostal space. Do you know what we mean by the intercostal space? What's that mean?
there a space on the cavity?
The space, who can correct him?
Between the rib?
Yes, thank you. So it is the space between the ribs. The intercostal space, it is the space between the ribs. How many ribs we are having? 12 pairs of ribs we are having. So the apex, the heart, it is up to the level of the fifth intercostal space. So this information is needed when we are doing ECG in order to put that leads that we are putting to get the ECG for the patient. So the location of the heart, it is in the thoracic cavity. This is the thoracic cage. This is the first ribs. This is the first intercostal space, the second intercostal space, third, fourth, and this is the fifth intercostal space. So it is at the fifth intercostal, up to the fifth intercostal space. It is from the second to the fifth intercostal space. So those are the ribs, as we said, and those are the intercostal space. The space between each two ribs, it is called intercostal space. And this is the xiphoid process. So the sternum, it is divided to three pieces. The head or manubrium, the body, and the xiphoid process. If you remember when we took this session of CPR, we told you that we will put our hand over the middle of the sternum here when we are doing compression if the heart is stopped. So because in this case, this part, it will be over the heart. So when we are compressing the heart. So this is the fifth intercostal space. And here, this is the diaphragm. So the heart is lying over the diaphragm. It is behind the sternum. The two lungs are, it is in between the two lungs. So this is when we are getting X-ray, we will see that the heart, it is like this. There are some X-ray which is better than this one. This one is not clear well. So this is the heart here. Usually in the X-ray, the size of the heart, it is 1/3 of the chest, of the diameter of the chest here. In order to, this is for your information, in order to see if the heart size is not within normal size or not, it has to be 1/3 of the diameter of the chest. Okay? In this case, see the heart. Is it normal? I gave you this information before. Is it normal here? The heart size?
No.
Why?
Big.
Because it is more than half of the chest diameter. So this part, in this X-ray, it is enlarged. So it is more than normal. So, as we said, the location of the heart, check out, we will see it on the torso. I will show you that. It is between the two lungs, it is over the diaphragm, and it is beneath the thoracic cage. Do you know what is covering the heart? from outside? You study, what's that? Two. What we call it that, those layers? It is covered by two layers of what? What type of? It is covered by serous. Yes, thank you. So it is covered by a serous membrane. Two layers of serous membrane. So two layers of serous membrane are covering it. The parietal, which is the lining of the cavity, and the visceral or the visceral, which is covering the organs. There is space in between those two layers, which contains serous fluid. So there is space between the two layers, which contain serous fluid. The function of it, it will lubricate and stop friction of when the movement. So it will make the movement easy of the heart. The contraction and relaxation of the heart, it will be easily because of the serous membrane, which is coming around the heart muscle, and it has that serous fluid. So when you study the membrane, you study the serous membrane, and this is one of the serous membrane. If you remember in secondary class, you took it as اللي هو غشاء التامور بسموه. So the heart covering is the pericardium, which is about a double serous membrane. It is called the pericardium. The visceral pericardium, and which is next directly to the heart, over the heart muscle directly. Then also it's called the epicardium. So the pericardium or epicardium, it is directly over the heart muscle. It is the visceral, or called the visceral pericardium. Then the parietal pericardium. The parietal, it is the outside layer. The serous fluid fills the space between the two layers of the pericardium. About the wall of the heart itself. So this is the covering of the heart. Now we'll come to the wall of the heart itself. The wall of the heart, it is consists of 3 layers. When you studied the type of muscle, what did you remember the types of muscle that you studied?
Yes.
What are they? There are 3 types of muscle. Cardiac muscle, smooth muscle, and skeletal muscle. So here we are, the cardiac muscle, it is only present where? In the heart. So we will not find the cardiac muscle anywhere except in the heart. So it is consists of 3 layers: the epicardium, which is outside layer, the visceral attached to the visceral pericardium. Then it is connective tissue layer. Then we have this is the epicardium or the membrane outside. Then the myocardium, which is the heart muscle, which is the middle layer. Mostly it is cardiac muscle. And we have the endocardium. The endocardium, which is the inner lining of the heart, or the endothelium. It is consists of endothelium tissues. So the pericardium, which is covering the heart from outside with the 2 layers, then the heart muscle, then the endocardium. The heart muscle, it is consist from the cardiac muscle, or myocardium, which is the cardiac muscle. So this is the composition of the layers of the heart. So the myocardium, it is the strongest muscle that has the ability to contract and to work for the whole life of the person. So the wall of the heart, if we are taking this part of the wall of the heart, this is the two layers of pericardium and or the epicardium, the visceral and lateral parietal lateral, and this is the fluid in between, the serous fluid. Then this is the layer of cardiac muscle, which is thick layer. When we are coming to the right and left side of the heart, we find that the left side, which side is more thicker, the right or the left? I will ask you. Left. Why? Why the left side? Yes, it is the left side. Which is, the wall of it is more thicker. Why? But raise your voice. I can't hear you well. Huh?
Because the lungs.
Because?
Lungs.
Lungs? Oh. Why? I didn't understand what. It is not because of the lungs. What's the function of the left side of the heart? And what's the function of the right side of the heart? The right side of the heart?
Left to go the blood to body, and right to lungs.
Yes. So the lungs is nearby. So the force which is needed to push the blood toward the lung is less. Because of that, the thickness of the right side, it will be less. The left side, it has to push, it has to be more stronger in order to push the blood for all over the body toward the aorta. Okay? So this is the myocardium, and this is the endocardium, the epithelial tissue. This is the epicardium, this is the myocardium, and this is the endocardium or visceral pericardium, and this is the parietal pericardium. And in between, this is the pericardial cavity, which is filled with what? The serous fluid. So the cardiac muscle, if we are taking a piece of the heart, it is ring-like arrangement. It is like figure of 8 bundle in order to have more stronger contractility. But if we are taking the skeletal muscle or the smooth muscle, usually it is like a thread. Longitudinally it is coming. But here it is mostly a figure of 8. That figure of 8, it is in order to make it the contractility all over the chambers of the heart, because the heart is consisting of chambers. There is nucleus, intracardiac disc is there also, and the cardiac myofibril will be there. So this is the heart, the muscle, the heart muscle, and characteristic of the heart muscles. Then we will come to the heart chambers. How many chambers is there in the heart? So there are 4 chambers. What are they? What are the 4 chambers of the heart?
Right, left,
Right,
and left.
right and left. There is, yes, it is divided to right and left. In the right, how many chambers are there? 2 chambers is there. In the left side, also 2 chambers is there. What's the chamber which is coming up?
Chronic.
Chronic? No? It is the atrium. So it is atrium, right? We have right atrium and down right ventricle. Then in the left side, left atrium and left ventricle. So there are 4 chambers. The atria, 2 atrias are there, and the atrias, they are receiving blood. The right is receiving the blood from where? The right atria is receiving blood from where?
Left, two, nice.
From the body. So the right side, the right atria, it receives the blood from the body. The left atria, it will receive the blood from the lung. Yes, thank you. So right atrium and left atrium. The right atrium to receive the blood from the body, and the left atrium to receive the blood from the lungs. Then the ventricles, we have 2 ventricles. The function of the ventricles is to push the blood either to the lung or to the body. Which part is pushing the blood toward the lung? Which ventricle?
Right.
The right ventricle is pushing the blood toward the lung in order to yes, to get oxygen, yes, to be oxygenated. So it's discharging chamber or pushing chamber or compressing chambers, the right ventricles and the left ventricle. The right ventricle, it will push the blood to the lungs, and the left ventricle, it will push the blood to the aorta and all over the body. So those are the chambers. What is this chamber? This one? Huh? This is the right atrium. And this portion, this chamber, right ventricle. And here, left atrium, and here, left ventricle. So those are the 4 chambers. What is this which is coming out from the right ventricle? This one. What is this? The blue one.
Artery.
Sorry? Artery. So, what's the name of this artery? It is, yes, it is the pulmonary artery. So, it is pushing the blood toward the pulmonary artery in order to go to the 2 lungs. See, there are 2 divisions here, right and left pulmonary artery. And مرة واحدة. Those are, this one, is it artery or vein? Vein. What did do you know what's the name of this vein? Hmm? I didn't want you to look in your book. No. This is inferior vena cava. Inferior vena cava. And this one, it is the superior vena cava. This one is bringing the blood from the lower part of the body. And this one is returning back the blood from the upper part of the body. So in inferior and superior vena cava, they are linked with the right atria and supply and returning back the blood to the right atria. This one, this big one, it is an artery. It is the aorta, the main artery of the body. It's the aorta. And there are the valves. We will come to those valves. This is the so we will come to those valves. This is the tricuspid valve, and this is the bicuspid valve. So this is the right atrium, left ventricle. This is left atrium and left ventricles. Those chambers, the above, as we said, they are for receiving. They are receiving chambers, receiving blood from either the body from the right side and from the lungs from the left side. And this is discharging chambers that push the blood out of the heart toward either the lung or toward the body. This is the superior vena cava, and this is the inferior vena cava. Those are the main two veins that bring back the blood to the heart, to the right atrium. And this is the pulmonary trunk, which divided to two pulmonary artery, the right and left pulmonary artery. And then those are the four pulmonary veins. Two are coming from right side and two are coming from the left side, and they are returning the blood to the right, to the left atrium. This is the aorta, and this is the arch of the aorta. So those are the main blood vessels that connected to the heart. Then we will come to the valves. So the valves, when there is any valve, what's the function of any valve? What valve is there? Either in our body or outside, when we are having any system of circulation, either water or gas or what. When we put valve, what's the purpose of that valve? What's the purpose of valve when we connect valve to any circulating system? To control what? Yes, thank you. So it is to control the direction in order to keep the fluid which is going inside that pipe, regardless to what is it. Is it the in the circulation here, or in gas circulation or water circulation? It is to keep it running in one direction, to prevent returning back of that fluid. So this is the purpose of the valve, that it will keep the fluid moving in one direction. So allow the blood to flow only in one direction. So there are 4 valves. The atrioventricular valve between the atria and the ventricle, those are the valves inside the heart itself. So we have the atrioventricular valve between the atria and the ventricles, and it's called the tricuspid valve. Then we have the bicuspid valve in the left side, the bicuspid valve, and the tricuspid valve in the right, and the bicuspid valve in the left. So this is the tricuspid valve, this one, we call it the tricuspid valve, and this is the bicuspid valve. We call it the atrioventricular valve. Atrioventricular valve. Yani the valves that coming between the atria and the ventricle. So there are 2 valves that come in between the atria and the ventricle. In the right side, it is the tricuspid valve. In the left side, it is the mitral valve or the bicuspid valve. Is it clear?
Yes.
So, atria, but the name of it is from the location of it. It is between the atria and ventricle. So because of that, it's called atrioventricular valve. In the right side, it is tricuspid valve. Tri it means 3. ثلاثي الوريقات. Tricuspid valve. In the right side, it is bicuspid valve. It is 2 leaves. So it is called the bicuspid valves. So the function of it, it will prevent the blood to come back to the atrium. So it will allow the blood to go to from the atria to the ventricle and prevent it from going back to the atrium. So this is the function of those 2 valves, the atrioventricular valve. So the atrioventricular valve, there are 2, one on the right and one in the left. In the right, it is tricuspid valve. In the left, it is the bicuspid valve, or we call it the mitral valve. This is the name of it. So ventricular valve held in place by collary tendons. There are tendons that fix it to the heart muscle, to the heart. It is the heart strings. So they are fixing it to the heart muscle. Small, those tendons that you saw as a threads. There is the similar valve between the ventricle and the atria, the artery, between the ventricle and the artery. There is those similar valve, pulmonary similar valve, which is between the right ventricle and the pulmonary artery. So it is between the right ventricle and pulmonary artery. The function of it, it is preventing the blood from coming back to the ventricle. It will allow it to go to the lungs, to the pulmonary artery, and preventing it from coming back when diastole is there, to prevent it from coming back to the heart chamber, to the ventricle. The aortic similar valve, it is in between the left ventricle and the aorta. It is between the left ventricle and the aorta. So it will allow the blood to come out from the left ventricle to the aorta and preventing it from coming back to the left ventricle during diastole, during the relaxation period. So the valve open as blood is pumped through. So when the contraction is there in that side, it will open and close according to the direction of it. Close to prevent the backflow. So it is open to allow the blood to go in its direction, and close in order to prevent the blood to go back. So again, those are the two atrioventricular valve. This is the tricuspid valve, this is the bicuspid valve, and this is the pulmonary valve, and this is the aortic valve. Tricuspid valves, this is the pulmonary semilunar valve, and the bicuspid mitral or mitral valve, and this is the aortic semilunar valve. Those are the coordinated tendons. Those are the tendons that fix the نعم I know. Okay, no problem. I will finish with this slide and then. So this is if we are taking a longitudinal transverse section. So those are the valves is coming like this. Those are the two atrioventricular valve, and those are the aortic and the pulmonary. This is pulmonary and aortic valve. So they are keeping homeostasis and the balance of the incompetent. If the valve is incompetent, it means that it is not closing well. In this case, it means that the blood, it will flow in both directions. So the next session we will continue with the heart structure and other structure of the heart. Thank you.